Okay, let's discuss electrical measurements. So let's first discuss the basic electrical quantities that is being measured. No? So I'm sure most of you medyo familiar na kayo dito sa sasabihin kong to. No? So the first is the electrical current or I. No? Electrical current, recall natin, it is the electrical charges or electrons in motion. No? Typically, makikita to sa isang conductor, no? Such as a wire. And electrical current is measured in units of amperes. Now, the second is voltage. So, ito naman yung responsible no, to flow the current. So, ito yung nagtutulak sa mga electron no, to flow para magkaroon ng kuryente. Also known as the electromotive force or EMF. Now, ito naman is measured in units of volts. Okay? Next is the resistance. No? Ito yung opposition to current flow. No, which is measured in units of ohm. So, ito yung Greek symbol niya. Yung nakikita nyo dito. Okay? So, next. Analog meters. No? I-recall natin dun sa first discussion natin. So, analog meters, it is the electromechanical device that drives a pointer against a scale. Basta, pag sinabing analog meter, yung output reading nyo is may makikita kayong pointer na gumagalaw. Okay? So, digital kasi is merong numeric display. Okay, so analog, merong pointer. So, yun yung main difference nilang dalawa. Okay? So, two types of scale na ginagamit sa analog meter is the linear scale and the non-linear scale. The linear scale, yung divisions or yung graduations, pag sinabing graduations, yung spacing ng mga markings or yung readings, is evenly spaced. No? While yung non-linear scale, yung spacing ng mga marking is unevenly spaced. No? Okay? So, two types of torque that are used to operate an analog meter, no? Which is, ito yung pinaka-importante. Kung wala itong dalawang torque, hindi gagana ang isang analog meter. So, first is the deflecting torque or T sub D. So, ito yung torque na responsible no, to deflect the pointer on a calibrated scale according to the electrical quantity passing through the instrument. Ibig sabihin, ito yung responsible para pagalawin yung pointer natin. Okay? While yung controlling torque, baliktad to, no? Ito yung opposite ng deflecting torque. No? Ito yung torque which opposes the movement of the deflecting torque. No? Kung walang controlling torque, dire-diretso yung pag-deflect ng pointer natin up to the maximum limit ng measuring device natin. Okay? And of course, pag wala din tong controlling torque, hindi rin babalik sa zero reading yung pointer natin. So, di ba? Sira yun pag gano'n, no? Pag walang controlling torque. No? Okay, so ito napaka-importante rin itong controlling torque na to. Okay? So at equilibrium, pag hindi na gumagalaw yung pointer or at steady state na siya, ibig sabihin na achieve niya na yung mini-measure niya talaga, no? Equal yung dalawang yon, no? Yung controlling torque and yung deflecting torque. Okay? So next, discuss natin yung three types of analog meters na ginagamit in today's industry. So, the first type is the moving iron meter. So, moving iron meter, ito yung type ng analog meter wherein it uses an iron no, to deflect the pointer for measuring current or voltage. No? Ganun lang naman ang ibig sabihin niya. No? Basta pag yung meter na yun gumagamit ng moving iron meter ang tawag. Diba? Okay? So, two main parts ng moving iron meter is first the solenoid. No? Pag sinabing solenoid, conductor wire na nakarap sa isang fixed iron. No? Solenoid ang tawag. Ay, ito yung responsible na to create magnetic field. And yung magnetic field na yon, no, papagalawin niya si moving iron which is yung second main part, no. Ito naman yung responsible no to deflect the pointer. Okay? So kung walang solenoid, walang magnetic field na mapoproduce, hindi gagalaw si moving iron. So, ano yung naiisip niyo na physics law dito no na nag-govern? 'Di ba yung Faraday's law of electromagnetic induction? So dito nag-a-apply 'yon sa analog meter natin. So hindi lang naman dito sa moving iron, dun din sa mga susunod na types ng analog meter. No? Mag-a-apply din si Faraday's law of electromagnetic induction. Okay, next. Working principle, paano ba gumagana si moving iron meter? No? So nasabi ko na nga kanina. Pero dagdag natin ng onte. No? Yung current na dumadaloy sa kanya. So, when the current to be measured or yung kailangan nating i-measure na kuryente ay dumaloy doon sa solenoid natin or doon sa conductor coil, it creates a magnetic field. Ngayon, itong magnetic field na to, no, ida-drive niya si iron na nasa gitna na nakikita niyo diyan na gumagalaw, no, para pagalawin yung pointer scale. Okay, so lahat yan, importante kung wala si pointer scale o kahit magkaroon ng magnetic field dyan, sinong gagalaw, di ba? Walang magiging reading din sa output. Okay, vice versa naman, kung wala naman si moving iron, di walang magkikreate ng magnetic field, hindi rin gagalaw si pointer scale. Okay, so madali lang yung working principle niya. No? Hindi ko na masyadong dinetail pa yung may mga Fleming's right hand rule pa. So wala na yung mga ganun. No? Basta diniscuss ko lang yung basic principle kung paano ba gumagana si moving iron meter. Okay? So of course, pag mas mataas yung kuryenteng dumadaloy dun sa coil natin, mas mataas din yung nakikreate na magnetic field, mas mataas yung deflection. Okay? So next, governing equation of a moving iron meter. No? Yung deflecting torque is equals to 1/2 I squared times dl over d theta. Where yung I natin, of course, yung current, dl over d theta, ito yung rate of change ng pagbabago ng inductance with respect to the coil deflection. Yung theta natin kasi is the coil deflection, where yung L natin is yung inductance. K is spring constant, o binibigay naman sa problem yan. No? If hindi binibigay sa problem, yan yung hinahanap sa problem. So, ganun lang naman yung dalawa, yung pagpipilian nyo. Pag wala si K, edi yun ang hahanapin nyo. Pag nandun, edi gagamitin nyo sa problem. Okay, hindi nyo naman kailangan pang hanapin sa calculator kung ano ba yung K. No? Okay. Let's have an example. No? A moving iron meter has 3 ampere moving in its coil. If it has a deflecting torque of 4 Newton meter, how fast does the inductance of the solenoid change with respect to the deflection? So, kulang tayo ng pen dito para makapagsulat tayo. Sulat natin yung formula. Ano bang tinatanong dito? How fast the inductance of the solenoid change with respect to the deflection? So, ang tinatanong dito is yung dl over d theta. So, TD is equals to 1/2 I squared times dl over d theta. So, ang hinahanap natin is yung dl over d theta. So, dl over d theta is equals to 2 times TD divided by I squared. So, equals to 2. Ano ba yung, I think binigay ata dito yung deflecting torque. 4 times Newton meter. 4 Newton meter pala rather. Divided by 3 ampere squared. So, ang sagot dito ay, this is, kaya ko bang i-mental to, no? 2 times 4 divided by 9. So, 8 over 9. Or 0.88 or 0.9. 0.9 Henry no, per theta. Siguro kahit lagay nyo na lang degrees, wala namang problema. Yun na rin naman yun. So, ito yung sagot natin. Okay, so madali lang, no? Straightforward lang. Okay, second type of analog meter is the moving coil meter. So, itong meter na to, no, uses a coil to deflect the pointer for measuring current or voltage. So, kanina sa moving iron ang gumagalaw ay yung iron, di ba? So, ito naman ang gumagalaw is yung coil naman. Okay? So, two main parts is permanent magnet. So, kung kanina ang nagkikreate ng magnetic field is the fixed iron na yung solenoid, no, na naka-wrap sa ng conductor, ito naman yung permanent magnet yung nag-create ng magnetic field. And yung gumagalaw dito is yung coil naman, no? To deflect the pointer. Okay? So, working principle of a moving coil meter. Ayan. Pag dumalo yung kuryente na yun, pupunta sa permanent magnet. And yung permanent magnet na yun, magkikreate ng magnetic field. No? Or yung nakikita yung magnetic flux lines na yun. Of course, the higher the amount of current na dumaloy, mas maraming magnetic field yung mapoproduce. Mas matlaki yung pag-deflect ni pointer. Okay, so directly proportional lang yung amount ng current na dumadaloy sa kanya doon sa napoproduce na magnetic field noong permanent magnet natin. Okay, so madali lang yung principle niya. No? Parang DC motor lang kung familiar kayo sa operation ng DC motor. Parang ganun lang siya. Okay, so of course nag-a-apply pa rin dito yung Faraday's law of electromagnetic induction. Okay? So, governing equation of a moving coil meter. So, deflecting torque equals B times I times N times A, where yung B natin is the magnetic flux density measured in Webers per meter squared times the current I times N, I think di ko ata nalagay dito yung N, pero yung N is the number of turns of the coil, no, times the area of the coil, which is yung A. And yung controlling torque is parehas pa rin ng formula dun sa moving iron, which is spring constant times coil deflection angle. Okay? So let's have an example. So the resistance of a moving coil voltmeter is 15 kilo ohms. Its coil has 100 turns and 30 millimeter long and 20 millimeter wide. The flux density in the air gap is 0.1 Weber per meter squared. Calculate the deflection angle at equilibrium produced by the application of 240 volts to the instrument if the control spring has a spring constant of 16 times 10 to the negative 7 Newton meter per degree. Oh, medyo mahirap pala ito. So, kuha tayo ng ball pen. So, sulat natin yung mga given. So, given dito is meron tayong resistance na 15 kilo ohm. Meron tayong voltage, 240 volts. And ano pa ba? May spring constant tayo na 16 times 10 to the negative 7 Newton meter per degree. Ano pa ba? Meron tayong flux density, yun, na 0.1 B. 0.1 Weber per meter squared. Meron din tayong number of turns ng coil, which is 100 turns. Ano pa ba? Yung dimension ng moving coil, no? I think ang dimension dito ang binigay is long tsaka yung wide. Yung gaano kahaba at gaano kalapad. So I think this is a square. No? Sinasabi naman sa problem yun kung circle ba siya. Pero kung hindi at dalawa lang yung dimension na binigay. So pag multiply nyo na lang yung dalawa. So ganun lang din naman yun. Hindi naman lahat ata talaga binibigay sa problem. Katulad nito, no? Hindi niya sinabi kung ano yung cross-sectional shape. Yeah? So ang area nito is 30 mm or 30 times 10 to the negative 3 meter times 20 times 10 to the negative 3 meter equals to 30 exponent to negative 3 times 20 exponent to negative 3, which is 0.6 millimeter or 0.6 times 10 to the negative 3 meter. So, calculate the deflection angle at equilibrium. Ayun, sinabi, equilibrium. So, ibig sabihin, TC equals TD. So, pag i-equate lang natin yung dalawang equation natin. So, K, theta for TC, for controlling torque, and for deflecting torque, B times I times N times A. So, ang hinahanap ay deflection angle, ito, theta. So, theta equals B na divided by the spring constant. So, 0.1 times, yung current natin is, gamitin natin yung Ohm's law. No, I is equals to V over R. So, 240 divided by 15 times 10 to the positive 3. Number of terms, 100. And singit natin si 0.6 times 10 to the negative 3. So, dapat naka-SI unit ha. Lahat naka-meters, lahat naka-seconds. Okay? Lahat naka-Newton. So, yun yung mga SI units. Divided by the spring constant, 16 times 10 to the negative 7. So, wala na tayong space. So, ilagay na lang natin dito. So, let me input the values. So, 0.1 times 240 divided by 15 kilo ohm times 100 times 0.6 exponent to negative 3 divided by 16 times or exponent to negative 7. So 60. So 60 degrees ang sagot for deflection. Sakto. 60 degrees yung deflection or coil deflection angle natin. Okay, last type of analog meter, which is the hot wire meter. So this meter uses a metal wire, no, that expands and contracts to deflect the pointer for measuring current or voltages. So, the two main parts of the hot wire is of course yung wire or the platinum wire. No, yung platinum kasi is pag nainitan kasi yan or lumamig, nag-expand or nagko-contract. Yun kasi yung characteristic niya or yung properties niya. No? Okay, so it expands or contracts when current passes through it. And the second is the silk thread and the spring. No, ito yung responsible to pull and push the platinum wire and also to deflect the pointer. Okay? So, working principle, yan, nakikita nyo, meron akong konting animation dito para mas maintindihan nyo. No? So, when the measured current flows, ayan, nakikita nyo, dumadalo yung kuryente dun sa platinum wire, ayun, nag-expand, no? Medyo nag-bend, no? Causing the wire, no, to expand or bend, no? And due to that, no, nag-deflect ngayon si pointer. So, of course, yung amount ng deflection is depende dun sa amount ng kuryente na dumadaloy. So, the higher the current, mas umiinit yung platinum, mas mataas yung, malaki yung pag-bend niya, mas malaki yung deflection ng pointer. Okay? So, ganun lang siya kasimple, no? Kung paano siya gumagana. Okay. So, the last governing equation for the hot wire meter, madali lang, no? Hindi katulad dun sa the first two, medyo madaming mga parameters. Ito is, I think, dalawa lang, no, for deflecting torque. Yung C is the proportionality constant, given naman niya, no, times I. Yung I is the RMS current moving in the coil. Yung RMS is equals to I peak divided by square root of 2. No, kung hindi na i-discuss sa inyo ito sa basics ng electronics or electricity, no, ito, sige, re-recall na natin kung ano yung conversion from root mean square papunta sa peak. Yeah. And ano pa ba? Yung controlling torque is parehas pa din naman, no? Spring constant times the coil deflection rotation angle. Okay? So, let's have an example. So, a hot wire meter has 1.5 ampere peak current. No? Take note, peak ha, hindi RMS. Flowing in its terminals. No? If the torque produced by the meter is 6.33 Newton meter, what is the meter constant of proportionality or yung C yung hinahanap natin? Okay, so mag-iba tayo ngayon ng kulay para maiba naman. So, given natin dito ay meron tayong current na 1.5 ampere. Hinahanap dito ay C. No? So, ano pa ba given? Torque. Meron tayong deflection torque na 6.33 Newton meter. So, solve natin. So, TD equals CI squared. So, 6.33 Newton meter equals C times 1.5 squared. So, C equals 1.5 squared 6.33 divided by 1.5 squared, which is 2.18. No, so 2.18. Ano ang unit nito? So, Newton meter divided by ampere squared. Okay, so, bakit naging ganito? Newton meter per ampere squared, no? Simple dimensional analysis lang naman, no? So, tingnan natin, no? TD equals CI squared. No? Ano ba ang unit ni TD? Newton meter. No, i-leave lang natin si C kasi yun ang hinahanap natin na unit. Ng unit eh. So, yung I is ampere, squared natin. So, ano yung C? So, Newton meter divided by ampere squared. Okay, so yan yung unit niya. So, ito yung sagot natin for constant of proportionality ng hot wire meter.